Welcome, students. I hope everybody is doing fine. And today we are going to start a new chapter that is motion. It comes under physics. Here we'll be talking about distance, displacement, speed, velocity, and acceleration. Okay, so we'll be able to explore how things actually move, right? So to begin with, what exactly a motion is? So whenever I say that we are, talking about or dealing with motion, first thing you have to keep in mind that every motion is relative to something. What do I mean by that? I mean that if something is moving, if we say that this person is moving, so we look around, the other places, and if we see there is a tree, okay, there is a tree like this, and the person went by it. Okay, so after a certain point, we'll see the tree is behind that person. So then only we can figure out that the thing or the man or the person was moving. Okay, so for example, you can imagine sitting in a car. Okay, so here this car is moving, like it has an effect of moving, right? But let's imagine that this is stopped car and you have just entered the car. Okay, now if you look around, you will see the trees like this, right? The buildings outside, they aren't moving at all. It is not in motion. Nothing is motion. You are not in motion. The trees are not in motion. But if you start driving, you will see that the same trees or the same buildings are moving behind and you are moving forward. That is what exactly you will feel actually. So that is motion. Okay, it's all basically relative change, the change which happened in context with something else. Okay, for example, I'm sitting in this bus and somebody else sitting beside, in different bus, and both buses are stationary. So there is no motion because I am, with respect to that person who's sitting in another bus, is at rest and they are also in rest. But once my bus started moving, I'll see that that bus stayed there and my bus started getting away from that bus, right? So that is basically nothing but motion. So an object is said to be in motion if its position changes. Okay, if I am at position A and I move to B with respect to my surroundings, maybe this is a house, okay, this is a tree. So my surroundings, whatever changes are occurring, that can be called as motion. A movement or change in position would be called as, the motion. Okay. Now moving ahead. So what is exactly a displacement and distance? Okay, what is the difference between these two? So let's again take an example of two different positions or places. So let's say this is your, let's say this is your home, A, and you have to go to your school building. Okay, this is your school, let's say. Okay, not so pretty, but yeah, we'll work with it. Okay, so this is place B or your school. Now you can you have a path to follow. You first go straight, then you go left, then you go maybe again right. Okay, then you go straight, and after that you go here. Okay, right side, and then again left, and then you reach your school. So that is the total length of the path traveled by you. That means, suppose if this is, 10 meters, okay, 10 meters. If it is 50 meters, okay, and if it is, let's say, 20 meters, let's not count this. You have reached, let's suppose. Okay, so this is the distance, is the total length of the path travel. That means 10 plus 50 plus 20. Okay, so 50, 60, 70, and it will be 80. 80 meters. So in 80 meters, after traveling 80 meters of length, you have reached your school. That is the distance covered. What is displacement? Displacement is the shortest distance covered, or the shortest straight line distance from your starting to your ending point. Okay, now for this, let's take another color. So from here, point A, if I make a straight line, point B to point B, that will be my displacement. Okay. So for example, again, let's take position A, position B. So if you are going to position B like this, no, this will be a distance. If you are reaching it like this, or maybe like this is all a distance. Okay. But if you go in a straight line, this is the displacement. Okay. Now, distance is again, one thing which you can, think about is if I started at point A, okay, and if I went 10 meters, 10 meters here, then I moved here, 10 meters, and here. So you can think that what would be the distance, okay, and what would be the displacement here. That is something you have to ponder and tell me in the comment section if you can, and I'll tell you whether it is correct or not. Okay, so the concept clarity you will get from this question. Now, coming to the distance again. So distance is a scalar quantity. What do we mean by that? That means it has magnitude but no direction. It is moving, like you can already see, right? Point A, point B. There's no direction. It is not going in one particular direction. It's going like this, any possible way. Okay. So think of it as an odometer reading in your car. The odometer reading is just to tell you the how much you have traveled, right? So it doesn't tell you which direction you have traveled in. But a vector quantity is something where the magnitude plus direction is there. So for example, maybe here you went in distance, you went maybe 10 meters. Okay, so it will be just 10 meters. The distance would be just 10 meters. For displacement, it would be 10 meters east. Okay, so it tells you how far you went and in exactly what direction you were going, right? Okay, so this is the difference between the distance and displacement. Now moving ahead with the speed. Speed tells us how fast we are going. So suppose if I'm covering a particular distance, in particular, let's say A, B, C, D. Okay, I'm moving from here to here, then again B to C, then C to D. Okay, these are my positions. I'm moving here, different places. Now, the speed would be how much time did I cover, to reach here? How much distance per minute or per time I have covered to reach here? That would be my speed. Okay, that means how much I can cover in a particular time. That's it. So speed is the rate of change of distance. For example, maybe I can from here A to B, I can go in, 10 minutes. Maybe my friend can go in 5 minutes only. So that means his speed is more. He can cover more distance, right? Double distance of mine in the same time. So that is basically the speed. Speed is the rate of change of distance. It tells you how quickly an object is covering the distance or ground. So formula of speed is equals to speed is equals to distance upon time. Okay, because in a particular time you are covering particular speed distance. That will give you the speed. Now units which are used usually would be meter per second. That means in few seconds, like 1 second, how many meters are you going? In another second, how many meters you go? That. Or we can use different units like kilometers per hour also. Okay, so if you're traveling like a very far place where you have to travel kilometers and kilometers, and the travel will be for hours and hours, then you can use this unit. Otherwise, for short distances, you can go with meter per second as well. Now, one example would be, let's say a car is traveling at a speed or a car travels basically a distance of 120 kilometers. Okay, and time is given 2 hours. So what will be the speed? Distance upon time, that will be 120 kilometers upon 2 hours. And that is nothing but, if you'll try solving this will be 60 kilometers per hour. Okay, so that means each hour you are going 60 kilometers. For first hour, you went 60 kilometers. And then second hour, again you went 60 kilometers. And that's how you covered your whole 120 kilometer. Right? So 60 kilometers you have traveled per hour. Okay. Now, velocity. So velocity is speed with a sense of direction. I have told you already this. So velocity is nothing but displacement upon time. Okay, so since it is a vector quantity, it considers both magnitude and as well as direction. So it will be displacement upon time. So now if somebody asks you what is the velocity, you'll first have to think, like, if they have given you shortest distance, right? This is 10 kilometers. And they have given you, this is how they can go also. And this is 50 kilometers. Okay, so and they asked you to calculate velocity. Go with the shortest distance because velocity is displacement upon time. Okay, and not distance upon time. So for example, if we take a car and it is traveling, it travels basically 100 kilometers east in east direction. Okay, so car took from here to here, it went 100 kilometers in the east direction and then stopped. Okay, in 2 hours. So you can simply calculate its velocity and come to a point that is 50 kilometer per hour in the direction of east. It is traveling, the car is traveling. Okay, so this is it about the velocity. Now coming to acceleration. So acceleration is basically the rate of change of velocity. That means what? That means something is going in this direction again. Okay, A and B. It's going from A to B in this direction. It started with some velocity. Okay, maybe very slowly or gradually it started. Okay, and then started moving with a speed of U. Then it changes its speed. Okay, because again you're moving to your, you're going to your home and you're getting late. So you have given the acceleration. Now your car, your bike, whatever vehicle you are using, it will start moving in a very fast rate, right? So that means you have changed from what you have started, what velocity you were using. You have changed from that to something else, that is V. So this was your initial velocity. And you have reached a final velocity. You thought maybe we can travel with this speed so that we can reach earlier. That's why you have put an acceleration, right? So to calculate the acceleration, we have to take the final velocity, and out of that, we have to remove the initial velocity. That will change, tell us actually the change in the velocity, right? Upon time. And that will give you the acceleration of anything. Okay, one example here you can see is if a car speeds up to 20 meter per second and it changes its speeds to 30 meter per second now. So 30 meter per second is the final speed, right? So 30 minus, what was the initial speed? 20 meter per second. What is the time? 5, right? Now, if you will try solving this, this will come out as 10 by 5. And again, you will solve it as 4 meter per second square. Okay, so this is the velocity. Okay, sorry, acceleration. Okay, velocity was this. We calculated the change in the velocity. Okay, so with this, we can talk about acceleration as well. Now, what is the, again, you can see the difference basically here. So, just a second. Yeah, so distance is a scalar quantity and it can be, its units could be this, meter and kilometer. Displacement, it's a vector quantity. That means it has a direction and its unit also would be meter and kilometer. Speed, again, speed is just, distance upon time. Velocity is having direction also. So it is a vector quantity and it will be removed by displacement. So this is displacement. Okay, upon time. Now these two are again given in the same units are being used, meter per second or kilometer per hour for both speed and velocity. For acceleration, it is a vector quantity again because you are giving acceleration in a certain direction, in a certain point, right? So this is V minus U, that is final velocity minus initial velocity upon time, which and its unit would be meter per second square. Okay. So I hope you have understood this so far. And you can try solving these questions by yourself and try giving answers to me. Okay. And if you have any doubt, so you can ask me. So the first question is define displacement. I think you can do that right now. Okay. Then question 2 would be a car covers 150 kilometer in 3 hours. Find its speed. So there is no direction involved. You can simply do distance upon time and try solving this. Question 3 is if velocity changes from 10 meter per second to 30 meter per second in 4 seconds, what is the acceleration? So I think this is also not tricky. You can find the change in the velocity and divide it by time. Okay, and the last one is name one example where distance is not equal to the displacement. So this you can, figure out. Now, thank you so much for joining the session. I hope you enjoyed this, new session of motion chapter. And you can contact me at Urban Pro for any kind of queries or doubt. Thank you. Bye-bye. Take care.